Hello student, I am Dr.A.K, Professor of Chemistry. Now I am going to discuss standard enthalpy of combustion. Last class I have discussed His law. Okay. Now I am going to discuss standard enthalpy of combustion. And its symbol is delta H, that is okay, that is the common. Here for the combustion we are using the word C, a small c. Delta, down you can write a small c and H. Okay, and upside the H, you know that just like in a circle you write 2 point or one line, a small line you can write. That is the standard enthalpy combustion symbol. Okay, what is this combustion reaction? Now we have to understand. Combustion reactions are exothermic in nature. Always keep in mind, exothermic reactions are always, you can say, exothermic. Combustion reaction means delta H will be always negative. Even in our body, when this release this carbon dioxide, after the breathing we are releasing, that is the carbon dioxide. Then that carbon dioxide, if you will check it, then you will find it is warm. That is due to the exothermic reaction. And generally wherever combustion reaction will be there, then there carbon dioxide will release. That is certain. Okay, then release of carbon dioxide will be associated with heat. That is the delta H will be negative. Delta H will be negative. Inside of the body, whatever we eat carbohydrate, then there combustion will take place. Means oxygen we are taking, we are breathing oxygen, air. In air oxygen is there, and that oxygen plus carbohydrate what we ate for what we ate in our food, that is maximum will be the carbohydrate, and this carbohydrate plus oxygen both will react. Then after the reaction it will form carbon dioxide plus H2O, means water, plus heat. Then this reaction, combustion reaction, in our body also takes place, correct? And it releases carbon dioxide plus heat. That both heat it is coming from our nose. Okay, then inside our body also combustion reaction takes place. Combustion reaction means always for the burning oxygen is required. That's why even wood will burn, coal will burn, we require oxygen. Any fuel, petrol, diesel, kerosene, just for the burning it requires oxygen. Then oxygen and this carbon is must. Hydrocarbon, compound of carbon and hydrogen is called hydrocarbon. Okay, then this here for combustion oxygen is essential, and after the combustion carbon dioxide will form, because generally hydrocarbon or carbohydrate, their oxygen will be also there. Carbon, compound of carbon, hydrogen, oxygen. Okay, that is called hydrocarbon, carbohydrate. In carbohydrate, three things will be there: carbon, hydrogen, oxygen. Either you can tell glucose or sucrose. Okay, glucose, sucrose, fructose, all are called carbohydrate, and they contain carbon, oxygen and hydrogen. That's why when it will burn, combustion means burning. Combustion means burning. Then whenever carbohydrate or hydrocarbon will react with oxygen, then two products will be common, that is the carbon dioxide and water. And third also, that is the heat These three things will be common in any combustion reaction. Now I am telling related to that only. Okay, combustion reactions are exothermic in nature. These are important in industry. In industry, this reaction will generally it is used. And rocketry, that is called rocketry. Okay, in rocket also fuel will be there, na? Diesel, petrol, sometimes helicopter they will use in emergency, kerosene also. Then there also combustion will take place, that is called rocketry. And other walks of life means wood burning, and even for this LPG, wood, coal, that from everywhere this heat will be produced, means combustion will take place. Then these I told you these are important in industry, rocketry and other walks of life. Standard enthalpy of combustion is defined as the enthalpy change per mole. Enthalpy change per mole or per unit amount of a substance when it undergoes combustion, and all the reactants and products being in their standard state at the specific temperature. Means reactant and product, they should be in their standard state. Means temperature, pressure is I told you 1 bar pressure, temperature that is the 273 Kelvin. Normal temperature is 273 plus T, that is 25 degree, 298. Okay, but standard if we will talk, then pressure will be 1 bar STP, that is called, and temperature should be 273 K. Cooking gas in cylinder contains mostly butane gas. Actually, this cooking gas, I am talking about LPG. There it is a mixture of two gases, butane and isobutane. Question will be asked, what is the LPG? The LPG, that will be the mixture of butane and isobutane. Option they will give only butane. Other time they will give only, second option will be isobutane. Third option may be mixture of both. Fourth option any other thing they may give, like they can give pentane or anything they can give, pentane, hexane, anything. Then here which is the correct answer? Then correct answer is mixture of both butane and isobutane. If mixture is not given, only butane is given the option, then you can write the correct answer as a butane, but it is the mixture of both butane and isobutane. Okay, then cooking gas in cylinder contains mostly butane. During complete combustion of 1 mole of butane, it will give you 2658, means 2658 kilojoule of heat. See how much heat it is producing, 1 mole. 1 mole of butane, it produces 2658, means 2658 kilojoule of heat. Okay, it is releasing 2658 kilojoule of heat, 2658. It is too much. And this reaction how we can write? Then butane means what? CnH2n plus 2. This is the formula for to write alkane. Actually for 11th student might be not knowing, but 12th student might be knowing. Okay, then now butane formula is C4H10. Actually alkane, this is alkane. Then alkane formula is CnH2n H2N plus 2. Then if carbon is 4, Cn, then N is 4, Cn H2N plus 2. Then now H2N plus 2. Then 2N means 2 into 4, 8 plus 2, 10. Then C4H10. C4H10, actually organic chemistry, when I will start, that time I will tell in details. Then now C4H10, this is the formula for butane. Then now combustion means what? It will burn. Then for the burning oxygen is required. Then here also butane will burn, and for the burning oxygen is required. Hence C4H10 plus O2. Then both will react, butane will burn. C4H10 plus O2 both will react. Reaction will take place, and after that it will form two products. Already I told you what are the two products. Then it will give carbon dioxide plus water. Water means H2O. H2O liquid it will give. Okay. Then balanced equation if you want to write, then balanced equation will be like this. C4H10. Butane is the gas. C4H10 in bracket small g you can write. Plus oxygen. How many moles of oxygen? How many moles? Then moles will be 7.5. 7.5 moles. Okay. 7.5 moles of O2. Then 7.5, how will you write? Then you write 15 by 2. 15 by 2. 7.5 you can write by 15 by 2. Then C4H10 plus 15 by 2 O2. That will give carbon dioxide and water. Then how much? How many moles carbon dioxide it will give? Then 4. 4 moles of carbon dioxide means 4 CO2. Then water, how many moles of water it will give? Then 6 mole. 6 mole means 6 H2O. Then balanced equation will be C6H10 plus 15 by 2 O2, and product will be 6 CO2 plus 5 H2O. Actually you make habit to keep your notes book plus your pen you keep always, and important things if you require you can write it down. Okay. Then this is the complete reaction balanced equation, and how much heat it will produce. What is the delta H value? Then delta H value will be minus 2658, means 2658.0, means exactly 2658 kilojoule per mole. Okay, this is the example of combustion reaction. Similarly, other example I will tell you. Similarly, combustion of glucose, that is the C6H12O6. Its formula, glucose formula is C6H12O6, glucose. Okay. Then this, if it will burn glucose, then again oxygen is required. Then glucose plus oxygen, it will give two products, carbon dioxide and water. Water means H2O. Then what will be the balanced equation? Then C6H12O6. Okay. Actually, this whatever glucose I am telling you, this is a solid. This is a solid, white color, you know. Sucrose just like ordinary sugar. Solid is there. Glucose is also white color, solid. But here, in this case, you have to write G, means gas, in bracket. Why? Because generally when we are taking food in our body, I am talking about in our body, that when we are eating, then it will be carbohydrate. a starch we are eating, a starch, big unit, then that will slowly and slowly it will break into a small and a smaller pieces. Then finally it will convert to the glucose, and that glucose, because in our body always body will be warm, then it will during the combustion, because oxygen we are taking inside, air we are taking, breathing, then it will burn inside, and when it will burn it will release too much heat. Then due to that heat, this glucose which was solid, now it will convert to the vapor form, or you can take gaseous form. That's why here in the reaction you should write C6H12O6 G, a small g in bracket you write, plus how many moles of oxygen is required? Then 6 mole of oxygen is required, 6O2. Then how many it will give carbon dioxide and water? The how many carbon dioxide gas it will give, how many moles of carbon dioxide? Then 6 mole. And how many water molecules it will form? Then 6. This is the balanced equation. You can balance by your own also. C6H12O6 is there. Then obviously 6 CO2 will come, because carbon has to balance. You can atom wise you can also balance, not a problem. But if you will remember, some hint you can get atom wise. But what main thing is that for balancing, you should know the main products. If you are knowing the main products, then quickly you will balance it. Without knowing the product, you can't balance. Then here you should always know what are the products, what products are giving. After that you can balance it. Okay. Then here glucose, that is a C6H12O6, that is in a gaseous form, it will react with oxygen, means 6 mole oxygen, and product it will give 6 carbon dioxide plus 6 H2O. And delta H how much? Then delta H will give 2802 2,802.0 kilojoule per mole, means 2802, this big amount. Okay, hence what we will conclude from this heat of combustion? From this you will do conclusion. See, when we eat, how much calories be required? We need energy to do the work, for whole day work, from morning to night. From morning to night we will be doing some work. Then in that actually some value is, fixed value is there, around 2500 kilocalorie we require. Okay, we require that amount of heat for whole day work. And here you are getting 2800 roughly you can understand, 2802 kilojoule. 1 calorie is equal to 4.18 joule. Keep in mind, calorie is bigger than joule. Okay, don't forget relation. 1 calorie is equal to 4.18, generally 4.2 you are writing just in a rough way. Then 1 calorie is equal to 4.18 joule, roughly 4 times more calories is there. Then we require, for whole day work, we require 2500 kilocalories. But by this glucose you are getting, for 1 mole, from 1 mole glucose you are getting 2802 kilojoule energy you are getting per mole. Okay, then this is the 2 example I have given. And already I told you our body also generate energy from food by the by the same overall process as combustion, although the final products are produced after a series of complex biochemical reaction involving enzymes. Okay, here I want to tell you again important things that this from the complex molecules like a starch, it will break into a small and a smaller, means a starch will break into sucrose, sucrose will break into the glucose, and after converting that into the sucrose, suppose sucrose will break into the fructose and glucose. Then what is the difference? Chemical formula is same, 6H12O6. For fructose also same, for glucose also same. Both are isomer. Then what is the difference in both? Then they differ in their group. That this glucose have ketonic group, CO group, ketonic, and glucose have aldehyde group, that is the CHO group. This is the different. And after that, when it is sucrose in the presence of water, it will convert into the glucose and fructose. And biological catalyst outside we are telling catalyst, but inside body that catalyst is known as biocatalyst, also called enzyme. Then in body many reaction will take place. Then for each reaction one special catalyst will be required, that is called biocatalyst, or in a biological term we are telling enzyme. Then for each reaction many enzymes are specific enzymes are required. For each reaction one catalyst, that is the biocatalyst, also called enzyme, is required. Then in this case also that catalyst like zymase, Z-Y-M-A-S, zymase is required. Then this sucrose means sugar, that is formula is C12H22O11. That is a common sugar what we are eating daily. Then C12H22O11 plus H2O. This reaction will take place in presence of H2O and enzyme. Then it will give this glucose, 1 mole of glucose, 1 mole of fructose it will give. After that, these glucose or fructose, again in the presence of suitable enzyme, again it will give two product. What are that two product? Then one will be ethyl alcohol, C2H5OH, ethyl alcohol, plus other product carbon dioxide plus heat. Then see, this is the reason why we are releasing carbon dioxide from our nose. Then this is the one more reason I am telling you, this reaction. And after the eating, particularly rice, if you will eat, then you will feel sleepy because of formation of ethyl alcohol. Ethyl alcohol, I told you, it is just like a wine, W-I-N-E, wine. And in wine, main composition is of ethyl alcohol, around 55%. Other things will be fruits, juice and water like that. But main composition is ethyl alcohol. That's why we feel sleepy. Okay. Then this reason I telling you why we feel sleepy after taking food. Okay. Then this is due to this reaction only. And also main reaction with combustion reaction, when major food starch and sucrose, starch or sucrose, when it will burn, that time also carbohydrate, many type of carbohydrates are there. The sucrose and glucose, fructose, maltose, these are the examples. Okay. Then whatever carbohydrate will burn, then it will release carbon dioxide. That carbon dioxide plus this carbon dioxide, what I told you now, then all comes out, and all are combustion reaction. It produces heat. That's why our body will be always warm. Our body is just like an oven. It starts just with birth, and before death it stops. Before death, body becomes fully, you can say, cold, fully cold. If you touch dying person, then body will be fully cold. Okay. Then this I have told you, this combustion reaction. Now I want to discuss one numericals. Okay, numericals is asked. Numericals is asked in all examination. In all examination means particularly 11th also, 12th also, medical also, engineering also, advanced particularly long question is there, then advanced short question is there for mains or IIT mains or medical. Okay, big question also they are asking in CSIR NET examination. Then now I am just one question I am telling you, and then after understanding you can solve it. Question is little long, but I told you question will be long and answer will be short, but here little answer will be also long, because here full concept is there. Last class I have discussed, now we will not fill a problem in understanding. Then try to understand the question. If you understand the question, because all things you are knowing, answer you are knowing, only you have to think in a proper way. For this question looks tricky. It is conceptual, but you have to understand the question first, and then you think in a proper way. Then what is the answer, what you have to do, that you are knowing. I will not tell anything new here. Nothing new I am going to tell. Only you have to apply your mind. Okay, common sense you have to apply. Then question I am reading you, try to understand. Okay, this is long question, and little answer is also little more, not big. Then here question is that the combustion of 1 mole of benzene means C6H6, that is called benzene. Benzene chemical formula is C6H6, means 6 carbon 6 hydrogen, C6H6. Okay, this is the formula for benzene. Then question is like that. Let me tell the question. The combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atmospheric pressure. After combustion, carbon dioxide gas and H2O liquid are produced, and 3267 kilojoule of heat is liberated during this reaction. This is a combustion reaction. What I discussed like that way, benzene after burning, benzene after combustion means C6H6 plus O2, it is giving CO2 plus H2O, and how much heat it is producing, delta H, then minus 3267 3267.0 kilojoule of heat is liberated. Calculate the standard enthalpy of formation. Delta F you have to calculate, a small f formation. Calculate, you can tell this in combustion. Calculate the standard enthalpy of formation. Also we can tell formation, combustion value they have given, the formation. Question is asking formation. Delta F, a small f means formation. Calculate the standard enthalpy of formation of benzene, means during the formation of benzene how much heat was liberated, that you have to calculate. Okay, standard enthalpy of formation of CO2 and H2O are minus 393.5 kilojoule and minus 285.83 kilojoule per mole respectively they have given. In question they have given a standard enthalpy of formation of CO2 they have given, and a standard enthalpy of H2O also they have given. Then already you know that CO2 standard enthalpy of formation of CO2 already I told minus 393.5 kilojoule, last class I told you, and H2O formation, and H2O heat of formation, that is minus 285.83 kilojoule per mole. Already I have discussed last classes. Okay, all the things. Then in this question you have to calculate heat of formation of benzene. Correct? Then you know that benzene is formed from the carbon and hydrogen. Benzene, how they will form? Formula is C6H6. Then it means carbon, it will form from the carbon and hydrogen, C plus H2. Standard state is this only. Standard state carbon and graphite, what you are telling, plus hydrogen gas. Then it means C plus H2 product is C6H6. Then delta H value you have to calculate. Delta H value, how much it will be there, that you have to calculate. Then by common sense, I am not going to do anything, only I will give a hint. Automatically you will understand. Then see, this you want to know, C6H6, during the formation of C6H6, what will be the delta H, question mark. Then now first equation you have to write. 4 equation, whatever data I have given, 2 data they have given. And third, what you have to calculate, what have to form, means benzene. These three reaction you have to write. 3 reaction you have to write with delta H. 3 reaction you have to write, means 3 equation you have to write with delta H. Okay. Main thing is this only. Then how will you write this benzene formation? Then you know that C product is C6H6. It means 6 carbon is required. 6 carbon is required, then only C6 will come. Then 6C, reactant side you will write 6C plus 6 hydrogen should be there, 6 hydrogen. Then plus H2 is there. Then it means to bring 6H2, 3 you have to write there with hydrogen, 3H2. Then one equation is ready. 6C plus 3H2. You will get C6H6. One equation is ready. Delta H you don't know. But now reaction you have written. Now other 2 reaction again you have to write. What is that? Then they have given these things. Question they have given that for CO2 value they have given. Okay, a standard enthalpy of formation of CO2 they have given. What is this value? Minus 393.5 kilojoule they have given. Then what will be the reaction? Already last class I have discussed you. For this carbon dioxide is forming. Then how carbon dioxide will form? Then carbon dioxide forms from carbon and oxygen. Okay. Carbon and oxygen, CO2 will be formed. Correct? Then you have to write reaction for this also. The very simple reaction, C plus O2, CO2, and delta H value is given. Then this is the second equation you have written. Third equation, again you have to write. They have given formation of H2O. Its value is given according to in the question. That is the minus 285.8083 kilojoule. Then now H2O is forming. Then for the H2O, What is required? H and oxygen is required. H and oxygen is required. Then H2O means 2 H is required, means H2, only one H2 is required. Only one oxygen, H2O, only one oxygen is there, means half O2. Then H2 plus half O2, H2 plus half O2, that is the H2O, liquid will form L. And its value, delta H value is given minus 285.83 kilojoule. Then now 3 equation you have written. 3 equation you have written. Okay. And one more, according to the question, one more thing they have given. That is given in the question. You have made from your side, according to the data, you have written 3 equation. And one equation already they have given in question. That is, they have given the combustion of 1 mole of benzene. Combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atmospheric pressure. In question they have written. And after the combustion, they are forming carbon dioxide and H2O. Then this reaction also you have to write. They have written literally, means you are simply in what they have told, but you have to write in equation form. That is the fourth you can tell equation. Then this is forming CO2 plus H2O. Then after combustion of benzene, then benzene is C6H6. Then combustion means plus O2. Then product side you can write CO2 plus H2O. Then after the balancing, this reaction C6H6 plus oxygen, it will give carbon dioxide plus water. Then now we are balancing. Then here 7.5. Already I have told you combustion reaction that I told you about this. That was the butane. That was the 13 by 2, 6.5 O2. For the these things, for butane C4H10, 13 by 2, 6.5 oxygen is required. 6.5. But here you require 7.5, means 15 by 2 oxygen is required. 15 by 2 mole of oxygen means C6H6 plus 15 by 2 O2. Then it will give you 6 CO2 plus 3 H2O. Okay, this is the balanced equation. And according to the question, they have given heat formation 3267 3267 kilojoule per mole. That's enough. All things, this 4 equation total you have written. Then now what you have to do? You want 6 carbon. Okay, you want 6 carbon plus 3 H2. Then it will give, that is your benzene. This is the requirement. This you want. Then now with the help of these equation, total 4 equation you have written. Then one equation you want, requirement is for this benzene equation you have written, 6 carbon 3 H2, that is the requirement. Then now 3 equations are remaining. Then this, what is given in the question, this combustion of benzene, okay, that now you don't do anything, leave it like that. Then now only two equations you have to make change. You have to consider first these 2, means for water and for CO2. Then actually what you have to do, you have to utilize your mind now here, that you do such type of arrangement in these things, in equation for water and for CO2. You have written equation for water and for CO2. In that, you make such type of rearrangement you can do, means left to right, right to left, that other product should cancel. Other product which you don't want should be cancelled to each other. That you have to do. Correct? Then for that, after writing this, how will you cancel? I am giving hint. Okay. Then now you can say which equation, what you will do. I am giving hint. That is for these things. First you have to do CO2 you have done, C plus O2 CO2, that reaction, and water H2 plus half O2 is 2O. Then now this C plus O2 CO2, but in this you require actually to get 6 carbon 3 H2, and it will give product. That is your distance that you want, okay, that you desired. Then to bring the 6 carbon, how will you bring 6 carbon? Then you can say CO2 equation, what you have written there, C plus O2 CO2, there you multiply by 6, then you will get 6 carbon plus 6 O2 plus 6 CO2 you got, means 6 carbon you got. Now you have to bring 3 H2, then other equation is there, H2O equation. There you have written H2 plus half O2 H2O. Then now you multiplied that equation by 3. Then you will get 3H2 plus 3H2. From 3 you multiply everywhere. Then you will get 3H2 plus 3 by 2O2 plus 3H2O. Then now C, you got 6 carbon also, and 6 carbon plus 3H2 you got. Means these two equation you have to add. Okay. CO2 equation plus water equation you have to add. Then you will get, what you will get? 6C and 3H2 you got. Then after adding whatever is coming, means left side also you add, right side also you add, then you will find that other things are also coming. Other products are also coming which you don't want. Then what you have to do? After that equation, what they have given in the question, okay, that equation, just to reverse it. Because now you want C6H6. Then 6 carbon 3H2 you got it. But C6H6 you didn't get. Then to get that things, question whatever they have given, benzene burning, combustion, that reaction you have written, that you reverse it. Then C6H6 will come in the right direction. Then see, then if you will reverse this, and what you got after adding H2 and CO2, that is after adding this 6 carbon and 3H2, that equation you added, then that equation add with this C6H6, what now we have reversed it and written, then that equation and this equation. After 6C and 3H2 you have written, after you have added, then you got one equation. Then in that extra things are there, but you want C6H6 also. Then how will you get? Then you will get from the question what you have written, benzene combustion, that you reverse it, and then you just add it. Then after adding you will find all things are going to be cancelled, and only what will remain, means 15 O2 will be cancelled, carbon dioxide CO2 will be cancelled, both will be cancelled out, because if right side CO2 is there and left side CO2 is there, then you know that both CO2 will cancel, because if you will bring both the left side, sign will change. Right side 6 CO2 as for example is there, and left side, right side 6 CO2 and left side 6 CO2. Both are in plus, then both will be cancelled out, because if you will try to bring right side, then it will, sign will change, minus 6 CO2 plus 6 CO2. That's why in that way it will be cancelled. Okay, H2O also will be cancelled. Then unnecessarily thing will be cancelled, and you will get what we are thinking. That is you will get 6 carbon plus 3H2 C6H6, and this delta H value also you add. Delta H value also you add, then you will get delta H value for this reaction, means 6 carbon 3H2, you got C6H6, that is actually liquid. Benzene is liquid, L. Okay, then this you got plus delta H value, after adding you will get 48.51 kilojoule per mole. 48.51 kilojoule per mole. Okay, this I have solved the numericals, and this is a little big, but not think big, it is interesting. It is interesting. Then this type of reaction, this type of numericals, many numericals are there, and only by this way you can solve many reaction. By use of this, what I have solved you, how to solve, I have told you. Then by use of this concept, you can solve other numericals also. Okay, don't fear from the numericals. Then now I am stopping only here, and next class again I will discuss other type of reaction. Thank you.